Hello everybody, this is Professor here. So today I will teach you integration by recognition. Okay, so integration by recognition, the principle is just that if you differentiate the denominator and you get a numerator, the answer for the integral is just the logarithm of the denominator. Okay, so let's start with the usual one, that is the easiest one. Okay, so let's have integral of 1 over x dx. So let's differentiate the denominator. If you differentiate the denominator, that is x, with respect to x, you get 1, right? Do you see that 1 is again the numerator? So the answer is just logarithm of the denominator, just ln x. Then don't forget to add a constant of integration, right? Okay, so for this we are done. So now let's go on and look at the integral. Now let's have integral of 1 over a x plus b. We are going to differentiate any function in this form. That is a linear function, right? As you can see, it's a linear function. So what do we do? Now I want you to recognize something. Try to differentiate the denominator. Do you see that if you differentiate, you just remain with an a, right? An a, because b is a constant to disappear. Ax is just, let's say, the same way as 2x, you just be remaining with x, right? So this is just ax, this is an ax. Okay, so you'll be remaining with just an a, right? But on top, that is on the numerator, we don't have an a. So what can we do? We can put an a on the numerator, right? So now do you see that we have changed the function? Is no longer the same. So how can we make it in such a way that we won't change anything? So we can just put 1 over a outside, right? So do you see that this a and this a can cancel out, and on the numerator will be remaining with a 1. So we didn't change anything. So I hope you are following me. Okay, so now do you see that if you differentiate the denominator, you get the numerator? So I said answer is just the logarithm of the denominator. So this will be ax plus ab, then we close bracket. But now we are not done yet. Do you see that we have a 1 over a on the outside of the integral? So we don't omit that one, we just write 1 over a. So this is our answer for integrating any function, any linear function of the form ax plus b being an inverse, that is 1 over ax plus b. Okay, so for that one we are done. Let's now look at a typical example. Now let's look at a typical example. So I will just work out one question. It says integrate 7 over 3x plus 1. Okay, so first of all, let's try to differentiate the denominator, right? If you differentiate the denominator, we get a 3, right? But on top we have a 7. So we can modify and multiply on top. Let's multiply on top by a 3, right? All over 3x plus 1. But do you see that we have changed the appearance of the integral? So what can we do to make it just the same as it was? So we can factor out 1 over 3 such that this 3 and this 3 can cancel out, and we'll be remaining with the original question that we had. So it means we haven't changed anything right now. Okay, so this will be equals to, now differentiate the denominator, you get a 3. Is it also on the top? Yes, because do you see that we can factor out the 7 here? So let me just first factor out the 7. 4 over 3 over 3x plus 1 plus 1, right? So now do you see that if you try to differentiate the numerator, you get a 3, that is the numerator again. So the answer is just logarithm of the denominator. So this will be 7 over 3 ln 3x plus 1, right? So for this question, we are done with this question, right? So let's see what else we can solve here. Okay, now let's go and see what's remaining.